Alright, so here I'm going to talk about the very simple but elegant law of sines. So the law of sines is like this. It says here, okay, let's just label these angles. So let's label it alpha and A, and then let's label it beta and B. Okay, so the side and the angles are related opposite. So now let's drop a perpendicular bisector here on this line of the triangle. So this is going to be a perpendicular line segment, and okay, let's just make it solid. And this is going to have height h. Okay. So by the definition of sine, sine is the opposite over the hypotenuse. So here in this right triangle, the sine of alpha is going to be the opposite, h, divided by the hypotenuse, b. The sine of alpha is going to be equal to h over b. Okay. Similarly, for this one, we also get this right triangle here, and it says that the sine of beta is going to be the opposite, h, divided by the hypotenuse, a. So sine of beta is going to be h divided by a. Now what does that do for us? Well, it actually allows us to simplify these two expressions together. So one thing is sine of alpha is equal to h divided by b. So multiplying this side by b, this gives us that h is going to be equal to b times the sine of alpha, right? Just moving b to that side, we get b sine alpha equals h. So h is equal to b times the sine of alpha. And now this one here says sine of beta is h over a multiplied by a, and we get that h is equal to a sine beta. So both of these things are actually equal to h. So what does that tell us? Well, that tells us that these two things has to be equal to each other, right? So just writing that out, it says that a sine of beta must be equal to b sine alpha because they're both equal to h. And now let's divide by b, and then here we divide by a, and what we get is that sine of beta divided by b. Okay, actually, so there's different forms for the law of sines, but yeah, let me just write it like that. So it says sine of beta divided by b is the same thing as sine of alpha divided by a. So that means the ratio. So similarly, we can also say that b divided by sine of beta is equal to a divided by sine of alpha because it's a ratio. You can always take the reciprocal on both sides. So it just says that the ratio of the sine of an angle to the opposite side in a triangle is going to be the same no matter which angle you actually pick. So if I pick this angle, then the sine of this angle divided by that opposite side is going to be the same thing as the sine of this angle divided by its opposite side. And that's true for any angle in a triangle. So if I label this last, because I proved it for two general angles, and I didn't really assume anything on the triangle, if I label this one gamma and this one c, that also says that the sine of gamma divided by c is also going to be equal to the sine of alpha divided by a. Just see that, you just rotate the whole triangle around, have this one as the base, and the proof goes exactly the same way. And so this is the law of sines, and it just relates an angle to an opposite side. So it's always the ratio of the sine of the angle to the opposite side is the same for any angle and any opposite side in the triangle. Now what are the implications of this? Well, one implication is that the sine of an angle is proportional to the side length. So the sine of an angle is actually always going to be increasing as your angle gets bigger. So this says that the bigger an angle is in a triangle, the longer the corresponding side length is going to be in that triangle. So one thing is that if I just look at the biggest angle in the triangle, then the side opposite to it will be the longest side. So that's one of the corollaries of the law of sines. Yeah, but the law of sines itself is just a simple formula saying that the ratio of an angle to its sine of an angle to the opposite side length is going to be the same for any angle on any opposite side in the triangle.